हेलो गाइस, आज हम करेंगे मेटलर्जी। So first of all we are going to do general principle of metallurgy. That is the topic of our today's presentation. So let's get started. Occurrence of metals. Metals occur in nature in two states, that is free state sometimes and in combined state mostly times. In free states, like lumps of pure metals that are called as nuggets, that are of silver, gold, platinum. These are also known as noble metals. And in combined state, like active metals, their compounds are known as minerals. Earth's crust is the biggest source of metals. Active metals occur in form of ores, where ores are the minerals from which metals can be conventionally and economically extracted. Ores. Ores are found in five types, that are sulfide ores, oxide ores, carbonate ores, halide ores, sulfate ores. Sulfide ores are of the sulfide ore of iron is known as iron pyrite. Sulfide ore of Pb is known as galena. Sulfide ore of Hg is known as cinnabar. Sulfide ore of Zn is known as zinc blende. Sulfide ore of copper is known as copper pyrites. Now, the oxide ore. Oxide of iron is known as hematite. Oxide of aluminium is known as bauxite. Oxide of manganese is known as pyrolusite. Oxide of Sn is known as cassiterite, and the oxide of ore of zinc is known as zincite. Now the carbonate ores. The carbonate ore of magnesium is known as magnesite. Carbonate ore of iron is known as siderite. Carbonate ore of Pb is known as cerussite, and the carbonate ore of zinc is known as calamine. Now, the halide ores. Halide ores are of two types, that is chloride ores and fluoride ores. Chloride ores. The chloride ore of sodium is known as rock salt. Chloride ore of silver is known as horn silver, and next one is KCl MgCl2 into 6H2O. This ore is known as carnallite. Next is fluoride ore. Calcium fluoride is known as fluorspar, and AlF3 into 3NAF is known as chirolite. Next one is sulfate ore. The sulfate of barium is known as barytes. Sulfate ore of Pb is known as anglesite. Sulfate ore of magnesium is known as epsomite, and the sulfate ore of calcium is known as anhydrite. So these are the some of the ores. Next, general principle of metallurgy. So let's get started with what is metallurgy. The process of extracting metals from their ores is known as metallurgy. Heavy metals like copper, iron, zinc, Sn, Pb, etc. are extracted from their ores by roasting and smelting processes. Active metals like alkali metals, magnesium, calcium, aluminum, etc. are obtained by electrolysis of their chlorides, oxides, or hydroxides. Next one is noble metals, that is silver, gold, etc., are obtained by amalgamation or cyanide process. Next are various steps involved in metallurgical processes. First is concentration of the ore, which is done by hand picking, gravity separation, magnetic separation, electrostatic separation, froth flotation method, and leaching. Next one is calcination, third one is roasting, fourth one is reduction to free metals like reduction by displacement, reduction by thermal decomposition, reduction by carbon that is known as smelting, reduction by heating in air, reduction by electropositive metal, and electrometallurgy. And the fifth one is refining or purification. So, the first one is concentration of ore. Concentration of ore is the operation which is performed to remove unwanted impurities, that is gangue, from the metallic ores. Concentration of ore is the operation which is performed to remove unwanted impurities from the metallic ores. The common methods of concentration of ores are handpicking, ores separated from rocky materials or impurities by simple handpicking or breaking with hammer. Second is gravity separation. Ore can be concentrated by this method when there is a difference of specific gravities of metallic ore and earthy impurities. That is, ore mixed with impurity, and then we grind it, then washed with running water, then light impurities washed away, heavy ore settle down. Third one is magnetic separation. That is, ferromagnetic ores that are affected by magnet are separated from non-magnetic impurities by means of magnetic separators. For example, मैग्नेटिक और प्लस गैंग, इसमें ये है, इसमें हमने कुछ इस टाइप का ये कुछ बना है। इसमें एक तरफ मैग्नेटिक रोलर है, एक तरफ नॉन मैग्नेटिक रोलर है, और उन दोनों के भी ऊपर हमने लगा दी लेदर बेल्ट, दैट इज नोन एज सेपरेटर। सो व्हेन, तो जब ये शुरू होगा तो मैग्नेटिक और सेपरेट हो जाएगा मैग्नेटिक रोलर की तरफ, एंड नो, और जो इम्प्योरिटीज होंगे वो नॉन मैग्नेटिक रोलर की तरफ सेपरेट हो जाएंगे। सो दिस इज द मैग्नेटिक सेपरेशन। नेक्स्ट वन इज इलेक्ट्रोस्टैटिक सेपरेशन, दैट इज पार्टिकल्स, मतलब ores with impurities which are good conductor of electricity become electrically charged when they are put in an electrostatic field, like PbS is a good conductor and ZnS is a poor conductor. Mixed ores are separated by this method. Fifth one is froth flotation method, which is based on the principle of preferential melting of solids by liquids. Example, metallic sulfides, that is melted by certain oils but not by water. Water plus finely powdered ore plus small quantity of oil, that is pine oil, in which water is vigorously agitated with air. Froth is formed at air-water interface. So it will be separated in two ways. The ore which is wetted by oil consists to the surface of froth or foam. Separate ore or gangue. The impurities or gangue are wetted by water remains in water below the froth. It's like this. Take a beaker, उसके अंदर गैंग है, उस गैंग के ऊपर वाटर प्लस ऑयल, उसके ऊपर फ्रोथ एंड फोम है, मतलब उसके ऊपर ऑरेंज सरफेस जो कि सेपरेट हो गया, और इसमें हमने एक ट्यूब से पास किया है जिसमें से एयर पास होगी. Okay. Sixth one is leaching. It is a chemical method of concentrating an ore. Powdered ore plus suitable reagent gives dissolves ore and impurities not dissolved. Example, bauxite plus NaOH. Bauxite is an aluminium ore, that is Al2O3 into 2H2O. NaOH हॉट लेना है जिससे हमें मिलेगा alumina dissolved in to form sodium meta-aluminate, and second is impurities left behind. Second, calcination. Second step in metallurgical process after concentration of ore is a process in ca ore is heated in absence of air or limited supply of air at a temperature insufficient to melt it. It is done to remove water from hydrated oxide ores and to remove carbon dioxide from carbonate ores, which are ore obtained after calcination is porous. That is, calcination of limestone gives calcium oxide plus carbon dioxide. Calcination of bauxite gives aluminium trioxide plus water. Calcination of iron ore gives iron oxide trioxide gives water. It is done in river battery furnace. Third process is known as roasting. Roasting is a process in ores, usually sulfide ores, are heated in presence of air at a temperature well below their melting points. It is carried out in a blast furnace. Sulfide ores plus air, heat in the presence of air मतलब ऑक्सीजन, तो ऑक्सीडेशन होगा, then ores separate हो जाएंगे and then impurities. Example, roasting of zinc ore gives zinc oxide plus 2SO2. Roasting of lead ore gives lead oxide plus SO2. Roasting of copper ore gives copper oxide plus SO2. Sixth one is reduction to free metal. Calcinated ore like Fe2O3 या फिर CaO etc. or roasted ores like PbO, ZnO etc. When these got reduced, they will give metallic states obtained. That is reduction by carbon, known as smelting. Metal oxide plus carbon on reduction where temperature is greater than 1000 degrees Celsius, we get free metal plus flux, मतलब additional substrate. Or impurities plus flux gives slag, which is not soluble in molten and metal, and it can be easily skimmed off from surface of molten metal. Smelting is done in a river battery furnace or blast furnace in controlled supply of air. For example, iron trioxide plus carbon at high temperature, मतलब melting point of metal से ज़्यादा temperature, we get molten metal, that is Fe plus carbon monoxide and carbon trioxide plus 3 moles of carbon monoxide gives metal plus carbon dioxide. Next is PbO plus carbon gives Pb plus CO. Next is PbO plus CO gives Pb plus CO2. Next is refining or purification. Metal obtained after various metallurgical operations is initially impure. Hence, it is subjected to purification. So, impurities mainly consisting of unreduced oxides and sulfides of metals, substance taken up in furnace, example slag, flux, etc. Other metals produced simultaneously on reduction of their respective oxides. Purification process depends upon the metal and nature of impurities under treatment. Various refining processes are liquefaction process, distillation process, oxidation process, thermal decomposition, electrorefining, zone refining. Liquefaction process used when impurity is less fusible than metal. Distillation process employed when metal to be purified is volatile. Example HgZnCd. Next is oxidation process employed for refining when impurities consisting of other metal get oxidized more reactively than metal itself. Thermal decomposition. In this process, oxide of metal itself is added, provide oxygen to the impurities, get oxidized easily. Electrorefining. Cu2O is added to impure molten copper to provide oxygen required for oxidation of impurities. Sorry, these are all for oxidation process. Next one is thermal decomposition. Impure metal converted into volatile compound, then decomposed into pure metal. In thermal decomposition, there are two processes, Mond process and one Arcal process. Mond process is used to refine nickel. One Arcal process is used for refining of ZrTi metals. Impure nickel in the presence of carbon monoxide at 50 degrees Celsius gives nickel tetracarbon monoxide on heating at 250 degrees Celsius in closed vessel gives nickel pure plus 4 moles of carbon monoxide. Whereas in one Arcal process, impure metal plus 2 moles of iodide on heating gives volatile Mi4 on electrically gives metal plus 2 moles of iodine. Fifth is electrorefining. Large number of metals are refined electrolytically. Means impure metal black is made anode. Pure metal plate is made cathode. Solution of metal salt is made electrolyte. That is, an electrolytic cell is constructed. Then, on passage of electric current, pure metal dissolves from anode. Impurities go into solution, anode mud, and the pure metal dissolved from anode get deposited at cathode. Next is zone refining. Zone refining is employed for preparing extremely pure metals. Impure metal on heating gives molten metal, which is allowed to cool, gives pure metal crystallize plus impurities remain in melt. This process is carried out in an inert atmosphere to prevent oxidation of metal. Some specialized techniques for extraction of metals. First is amalgamation. Process is used for extraction of gold which occurs native state. Gold extraction, that is crushed auriferous quartz plus mercury gives AuHg amalgam and distillation gives Au extracted. Next is hydrometallurgy. Or on addition of chemical reagent gives metal in solution. On adding precipitating reagent gives metal is recovered. तो Ag extraction के लिए होता है basically Ag plus 8 NaCN which is a chemical reagent plus oxygen means air plus water gives 4 moles of Na AgCN whole twice plus 4 moles of NaOH. Metal is brought into solution. Zinc turning डालेंगे हम, that is a precipitating reagent. We get Na2 ZnCN whole 4 plus Ag, that is metal is extracted out. Third is solvent extraction. Solvent extraction is employed in desilverization of Pb by zinc, which is Parkes process. That is argentiferous lead on heating at 800 degrees Celsius. We get melted Pb, which is on molten zinc added. We get two immiscible liquid layers that are of zinc and Pb. The lower layer is of molten Pb and the upper layer is of molten zinc. Then we get Ag solute more dissolved in zinc. So molten zinc added. By repeating this process again and again, more and more Ag passes into zinc layer and consequently desilverization of Pb occurs. So that's all for the general principle of metallurgy. That's it. Thank you.